So today in college algebra, we'll be looking at solving trig equations. Let's get this started. Okay. Now, an important part of this is looking at the domain of our trig equation. So our domain is going to be one time around the unit circle. So we're only looking for values at one time around. Okay, you can have an infinite number if you go multiple times around the unit circle, or just an infinite number of times around the unit circle. We just want to go once. Okay, so if it's not in one rotation of the unit circle, we're not going to look at it. So that means, unlike when we looked at the inverses before, everything on the unit circle is fair game for these problems. Okay. Now this is also where the unit circle is going to come in very handy. You should have it up and looking at it to solve these problems. And it works a little bit like the inverse problems that we were doing on Monday and Tuesday. Well, just Monday, actually. Excuse me. So what we're going to do is we're going to solve for our trig function. In this case, it's cosine of x. I'm going to find out where cosine of x and all the places of the cosine of x is negative root 3 over 2. Okay, so we're looking for the x value on the unit circle, that is negative root 3 over 2, and we're looking for all of them. So we want the radians. So the x value is negative root 3 over 2 at 5 pi over 6 and at 7 pi over 6. That is it. That's all you have to do. Let's look at number 2. So we want to solve for the trig equation. So we want to get the cosine of x by itself. In order to do this, this 2 is being multiplied by cosine of x. So we're going to divide it by 2. So cosine of x is equal to negative 1/2. So now we look at our unit circle. We're going to find out the x values are negative 1/2. There are two of them. 2 pi over 3. So, and the other one is 4 pi over 3. That is it. Those are the only two places where the cosine or the x term is negative 1/2. Just looking at number 3. Now, since we're dealing with equations, all the rules for regular equations apply to these. So if you could factor them, you could solve them, you could square root them, you could whatever. Okay, the same rules apply to this. So in number 3, we have sine squared plus sine. Well, because both terms in our equation have sine, we can take the greatest common factor of sine x out. This leaves us with sine of x plus 1, and that equals 0. Now, if it's the same kind of idea as if you had x squared plus x equals 0. You take a greatest common factor of x out, you have x plus 1. Okay, so it's the same idea, just using sine functions. Now we can set both of those factors equal to 0. So we have sine of x is equal to 0, and sine of x plus 1 is equal to 0. Now sine of x equals to 0 is all you need to do for that particular part of our equation, because it's already done. It's already got the trig function set equal to a number. On the other side, we have to solve for sine of x by subtracting 1. So if sine of x is equal to negative 1. Now we're going to find both cases. We're going to find where sine of x is 0 and where sine of x is negative 1. Okay, so for sine, it's the y value. We want to know all the places on the unit circle where y is 0. There's in fact 3 of them. Okay, there is 0 pi, there is 1 pi, and there is 2 pi. So 0 and 2 pi are in the same spot, but technically they're different radians. They are coterminal, but they are different radians. On the other side, we have sine equals negative 1. So where's the y value where it equals negative 1? It's only one spot. It's 3 pi over 2. So they're both answers. You've got to have both of them. Okay. Next, sine squared of x equals 1/4. Okay. So we have something that's being squared. So to get rid of squared, we square root both sides of our equation. So the squared and the squared will cancel out. We'll get sine of x is equal to, the square root of 1 is 1, the square root of 4 is 2, but when you take the square root of an equation, you have to put plus or minus in front of your answer, okay, because it has to account for the fact that you could have a positive or a negative value that when you square it, gives you the positive number. So now I'm going to find out all the places on the unit circle where the sine function is positive or negative 1/2. So all the y values that are positive or negative 1/2. So that would include pi over 6. That would include 5 pi over 6, 7 pi over 6, and 11 pi over 6. So all the pi over 6s, because it's positive or negative 1/2. Okay, moving up to the top. Number 5. So this is a equation that's already been factored for us. Okay, we could have multiplied it together and factored it ourselves, but thankfully for you, it was already factored for you. So what we can do is we can take both of our factors and set them equal to 0 separately. We solve them both for the trig function. So the first one, we subtract 1. So cosine of x equals negative 1. And the other one, we're going to add 1. Oh, Freudian slip. And then divide both sides by 2. Now, this doesn't have a plus or minus because I'm not square rooting it. I know some of you guys are thinking, well, this is like the last problem where it's plus or minus 1/2, but you're not square rooting anything, thus there's just one answer. Now, separately, we find out where the cosine on the unit circle is negative 1, so the x term has to be a negative 1. That only happens in one spot, that's at pi. We're going to find out where the sine value, the y term, is going to be 1/2. It happens twice, at pi over 6 and at 5 pi over 6. There we go. Number 6. Tangent plus 1 equals 0. So we want to solve for tangent. We're going to subtract 1 from both sides. So now, the thing about tangent, we're trying to be nice for these because it could make them ugly. We're trying to be nice. Where tangent equals negative 1, those are going to be one of the pi over 4s. Okay, we're looking for negative 1 because, and we know it's going to be the pi over 4s because the y and the x term are the same number, and when you divide a number by itself, it just equals 1. It just happens ours needs to be negative. So we're looking at the pi over 4 radians on the unit circle. We're looking for one of the values to be positive and one to be negative. This happens twice, at 3 pi over 4 and at 7 pi over 4. At the other two spots for pi over 4, it's a positive divided by a positive, which will give you a positive number, and then a negative divided by a negative, which would also give you a positive number. Number 7, sine squared minus 1 equals 0. So before we square root both sides to get rid of our squared sign on the sine function, we have to add 1. So you have sine squared of x equals 1. Now, to get rid of the squared part, we can square root both sides of our equation. Squared and the square root will cancel each other out. We'll have sine of x is equal to 1. But again, just like in the problem previously, when we did number 4, when we take the square root of both sides of an equation, we have to put down plus or minus 1. So we're looking for where the sine function is either positive or negative 1. So the y value is going to be positive or negative 1. This happens twice. First time was at pi over 2. The other time was at 3 pi over 2. So all the things we've done so far are just regular solving equation type things. It's just dealing with trig functions. And number 8, we have a quadratic. Okay. This we have to factor. Now, if it's hard to see it this way, think about it in terms of just if we got rid of the cosines and we had 2x squared plus x minus 1 equals 0. That quadratic would represent the same thing we have in our trig function equation. So we can factor this. The two terms that make up 2x squared would be 2x and x. And then the two numbers that multiply together to give you negative 1 would have to be 1 and 1. It's just we have to work with the signs. The term in the middle has to be positive, so that means this one has to be positive, and the other one has to be negative. And the reason I know that is because when you multiply it out, the 2 here times this 1 would give you 2x, and the negative 1 here with the times the x would give you negative x, and this together would give you positive x, which is what we're looking for right here. So, if we factor that quadratic, we can factor the other one. It's the same thing, except we're going to replace the x's with cosines. So 2 times cosine minus 1 cosine x plus 1 equals 0. Now that we have our factors, we can take our two factors separately and set them equal to 0. If we add 1, we get 2 cosine of x equals 1. Divide by 2, cosine of x equals 1/2. The other side, I'm going to subtract 1, cosine of x equals negative 1. So I'm going to find the radians for both of these. So let's start with the 1/2. So where the x term on the unit circle is 1/2 and positive, so we have two of those. It's going to be at pi over 3, and it's going to be at 5 pi over 3. And then for cosine of negative 1, where the x term is negative 1, that only happens once, at pi. So that is a bunch of different examples for solving trig equations. Please, it's really important you try the practice for these problems because students seem to struggle with this despite the fact that it is a lot of just looking at the unit circle. And the more practice you have, the better off you'll be. Okay, if you have questions, please ask. Please, if you're not done one of the tests so far, please reach out and find out and let me know when you're ready to take it, and I will assign it to you. Other than that, get to work and good luck.